Hello, my name is Juan, and I'm going to show you how to make an endurance track for Formula SAE on OptimumLap. First, search up Formula SAE Endurance Map and find a photo. Next, when you're on that photo, right-click and save it to your desktop. I'm naming my photo Formula SAE Track, and it should show up on your desktop. The next thing I'm going to do is try and find a relative dimension that I can match up to my photo. So if we look here at this overtaking straight and we draw a straight line from one corner to the other, we can see that it is between the 1,000 foot mark and just over the 800 foot mark. So I'm going to mark this blue line as about 200 feet.
We can see here in the rules that the maximum distance for a straight is 61 meters with Y turns on either end, and 200 feet is less than that. Next, I'm going to go into Solidworks and make a new part file, and then within this new part file, I'm going to create a new sketch. Then I'm going to draw a horizontal line and smart dimension it to be 200 feet long. I changed my units to meters, so that's why it says 60 meters there. After this, I'm going to use the sketch picture tool to import my photo of my FSAE Endurance Track into a new SolidWorks sketch within the same part file. From here, I'm going to scale up the photo until the straight matches the distance of my 200-foot line that I made in the first sketch. This will allow me to then trace the red parts of the track within the same reference dimension as that straight is. So what we're doing is we're basically creating a part that we know is 200 feet long, and then because that part is 200 feet long, the dimensions of everything else will be accurate to what the track is. Before I begin to mark out my track, I'm going to make a new OptimumLap project. So I'm going to open up OptimumLap and click New Project. And then from here, I'm going to go to Create Track, and I'm just going to name it. And so what's important here is to recognize the type, the section length, and the corner radius at the bottom. This is important because we're going to find the section length and the corner radius of each of the curves in SolidWorks. In addition, we're also going to reason through what kind of type it is. So next, you're going to go into Excel and copy this format down so that each time we add a new curve in SolidWorks, we will write it down in our Excel file. So now I'm back in SolidWorks in the original part file I made. I'm going to create a new sketch in the front plane, and I'm going to start tracing over the red line. So I'm going to create a 3-point arc circle and then a straight. Notice how I am clicking on each of the little blue circles before I am moving. I'm just clicking and then hitting escape and then continuing to trace. This is a very tedious process as you have to go around the entire track and trace all of the red lines. I'm going to show you how to smart dimension and get the dimensions of each of your lines next. So for the straight, it's pretty simple. You just take the smart dimension tool and you hover over it and you click it. For the semicircles, you want to get the radius of your arc, and then you also want to get the section length. To get the section length, you need to click on each of the two blue dots and then click on the arc and pull it away from you. So here you can see a straight, I'm just clicking on it and then hitting escape, and here you can see a semicircle. I'm doing the radius first, and then I'm going to do the section length where I hit the two blue dots, and then I click the arc, and you'll see that little dimension come up with the half circle over it. Once you're done tracing your track, it should look something like this. As you can see, I started labeling about half of my track, as I just wanted to check after I did a certain number of measurements that I was doing it correctly. Then if we move over here, we can see our Excel, where we have the section length, the corner radius, and the type. Then we move over here into OptimumLap, and we can see our track slowly starting to take shape. What I want to make a note of is the way OptimumLap works. So if I exit my sketch here and I overlay a new screenshot of the track that I just made in OptimumLap using Sketch Picture, and I expand it right about like that, you'll notice that the track doesn't really follow the parameters of my sketch that I did originally. And that isn't a deliberate choice. That is just something that OptimumLap does when you don't flatten out your curves. What I mean by flatten out your curves is by making the lines when they connect to each other tangent. So for example, if I go into OptimumLap and I have a curve with a section length of 10 and a radius of 5 and a straight, it's going to just kind of follow the natural progression of the end of the curve. Meanwhile, when I go back to my photo over here, if I have a line that looks like this in my track, OptimumLap is not going to follow this progression because it doesn't have a setting to do this. So what you need to do is you need to click on each point and you need to make it tangent, and then it will follow the progression of the curve. So that's one thing to know. Another thing that caught my attention was the section lengths of a track that is from the OptimumLap like import tool. This is an FSAE autocross track in Nebraska. And you'll notice here that it has a bunch of very small section lengths for each of its curves. It has, left 1 meter, 1 meter, 1 meter, 1 meter, 1 meter. And when I put these into Excel and I summed them all up, I got that the total distance of this track was about 791 meters. And then as I was making my own track, without even being halfway through, I summed up the section lengths of my curves and I noticed it was about 911 meters. And this posed a problem because an autocross track is meant to be approximately zero 0.8 kilometers, and I'm already way over the limit of that. And I went into SolidWorks and I checked my units. They were in meters, and I checked my sketch that it was scaled correctly. And it was, this line is about 200 feet. And so I honestly don't really know why it's doing this. I get the notion that they either made the track much larger or that there is something going on with OptimumLap.
So what did we learn? We learned how to import a photo into SolidWorks. We learned how to scale it up using a reference dimension. We learned how to dimension out curves to find their section lengths. And we learned how to import into OptimumLap to create a custom track. Questions we still need to answer are why this track is so dang big. It goes from 2,000 feet to 0 feet and from 0 feet to 600 feet, which if you take a big rectangle around it is already way longer than the autocross track that is in the FSAE rules. And so once we're able to figure that out, we should be able to import into OptimumLap as normal and get a track that would give us track times that resemble FSAE cars that actually run during the competition.